All right, so the software that Ball State has a license with to create these screencasts keep on failing me. So this is actually the sixth time that I've recorded this lecture. I'm hoping it works. Let's see. All right, so let's move on to the D climate zone. Now the D climate zone includes the specific climate type called humid continental that applies to about two-thirds of Indiana, the northern two-thirds of Indiana. Now, for any climate type within the D zone, it is characterized by continentality, meaning being far removed from any major source of water that would otherwise moderate temperatures, and especially winter temperatures. So what that means is that every location that has a D climate type has severe winters. And as we are all familiar with here in Indiana, mean monthly temperatures are in the 20s, but lows can often be in the single digits or even below zero. Most certainly, for most of Indiana, winters are severe. And thus, we tend to also have high temperature ranges. So, summer, very hot, mean temperatures in the 70s, highs often in the 80s and 90s. But over the course of the year, the range in mean monthly temperatures is roughly 50 degrees Fahrenheit. And it's even more pronounced as we move upward within the northern hemisphere. In Canada and in Russia, the difference between the warmest month and the coolest month can often be 70 degrees, 80 degrees, or more. Now, this particular climate zone, D climate zone, and all of its different climate types are only found in the northern hemisphere. And the reason for that is because there is a lot more land in the northern hemisphere than within the southern hemisphere. And so thus, with much more land, you have that greater sense of continentality. Proceeding on here, summers are typically the wet season within these environments. So as I showed you earlier, May and June tend to be the wettest months in Muncie, and this applies to many areas that have a D climate type of any type. It tends to be concentrated in the spring and summer. Now, overall, it's somewhat, rather evenly distributed within Indiana, but most certainly there's a little bit of a concentration in the spring and summer. Precipitation exceeds potential evapotranspiration. So what that means is that even if annual totals for precipitation can be lower, for example, they tend to be lower as you make your way into Canada and into Russia, you can still have a green, lush environment dominated by trees because potential evapotranspiration is also low. Remember, potential evapotranspiration is a function of solar intensity, and if solar intensity is weaker in, let's say, central Canada, let me look at a map here. So where I'm hovering over right now, just randomly, is around Manitoba in Canada. That area or that province may only experience 20 to 25 inches of precipitation annually throughout much of it. It's still a province dominated by pine trees. It's very green there for most of it because potential evapotranspiration is also low. Specifically, the climate types we'll be considering within this zone are subarctic and humid continental. Humid continental applying to the northern, roughly two-thirds of Indiana. Now, for Indiana, it's a very boring state. Many people consider it a boring state because much of it is dedicated to agriculture. If you have flat lands that are pretty easily accessible with this climate type, humid continental, it's large around the world. These places are going to be mostly dedicated to agriculture because no season really dominates. Summer is about as long as winter and vice versa. It's not too wet. It's not too dry. Soil acidity is not too low or high. And so thus it's very well suited for many of your very lucrative forms of agriculture, especially those focused on corn, soybeans, or perhaps if it's a little bit drier, grains. So this applies to the Midwest, the northern two-thirds of Indiana, Central and Eastern Europe, northeastern China. So going back to the map here, so here's Central and Eastern Europe, much of it dedicated to agriculture. Here in northeastern China, for example, Manchuria, much of it is dedicated to mainstream agriculture as well. Now, the biome that is largely associated with the humid continental climate type is mid-latitude deciduous forest. So it's what we see here in this given shade of green. It says mid-latitude forest, mostly deciduous. So yes, you may find coniferous or cone-producing trees, but the dominant form of tree species tend to be deciduous, meaning trees that have leaves that shed. And so here's where I want to bring up the concept of plant succession. So it's pretty amazing how in nature, if you just let nature do its thing, it can quickly take over a very short period of time. And so let's say you leave a field to fallow and you clear it out, and all that is found at the time is a bunch of grass or maybe some flowering plants. Eventually, after a few years, those annual plants will give way to perennial plants, ones that come back every year for a given period of time. And then those perennial plants and grasses will give way to shrubs, bushes and short trees that then will eventually give way to coniferous trees, to pines, spruces, firs. In that process, they'll help to create a very acidic environment. The soil will be very acidic. And then because of that, only your sturdiest trees will kind of win out. And your sturdiest trees tend to be hardwood trees. And so in this particular climate type of humid continental, where there's no dominant season, your hardwood trees such as oak and hickory will eventually win out. And so it's pretty amazing that just over the course of a century and a half or so, an empty field would turn into an area dominated by hardwood trees if you just let nature take over. But we don't see that throughout much of Indiana, except for southern Indiana, because most of the state, especially the northern 2/3 of the state, is dedicated to agriculture. Now, ranging northward, north of our humid continental climate type, we have subarctic. Subarctic, as it sounds, is dominated by winter, and so we have many different subtypes here, specific climate types with these different lettering combinations, but they're just in reference to how intense and how lengthy winter is. Now, despite the colder conditions, at least 1 month must have a temperature that exceeds 50 degrees Fahrenheit. Otherwise, if you did not have at least one relatively warm month, then you would not have trees. You would not have forest growth. This particular climate type, subarctic, largely applies to large portions of Canada, Russia, Alaska. So as you might expect, in these areas, pine trees dominate. So here it's referred to as taiga in Russia and much of Eurasia. But boreal forest or taiga just means northern forest. The soil tends to be very acidic. These forests are very, very dense. The trees may not necessarily be extremely tall, but they are largely used for the very important lumbering industry. And as you might imagine, lumber exports are very important to Canada and to Russia. And so these trees can dominate because their hard, narrow needles are better able to withstand lower precipitation totals. So even if these environments are quite green, annual precipitation totals may only be 18, 20, 25, 27 inches, similar to what we talked about with the steppe environments. But the reason they don't look like a steppe environment dominated by grass or short shrubs is because PE, potential evapotranspiration, is also low. Another thing that I'm going to cover here is permafrost. Now, it's in these locations of Alaska, much of Canada, much of Russia, that with warming temperatures globally, these higher totals, these increased temperatures, or these increasing temperatures, are most pronounced in our Arctic and subarctic places. So what that means is that throughout much of Canada, throughout much of Russia, Alaska, we have many buildings, homes, forms of infrastructure like roads and bridges that are collapsing or falling apart or losing their foundation because they're actually founded upon soil that is frozen or partially frozen to a certain depth. And so as those soils, as these permanently frozen layers of soil start to recede, the structural integrity of those foundations are crumbling. And as mentioned, this is most pronounced in our upper latitude regions of the northern hemisphere. All right, we'll move on to the E climate zone in the next video.